Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 19 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this series of video lessons, and in this class we will be using the most excellent Sunfounder Raphael Raspberry Pi kit. Most of you guys probably already have your gear. If you don't, look down in the description. There is a link over to Amazon where you can pick up this most excellent kit. But enough of this shameless self-promotion and advertising. Let's talk about what I am going to teach you today. And what I'm going to teach you how to do is I'm going to teach you how to control a servo from a Raspberry Pi. Good news is we ought to have this up and running in about 10 minutes, so I'll show you how to do it. But I should give you a heads up that's a little more tedious to do it on the Raspberry Pi than it is to do it on the Arduino. To run it on the Arduino, you just hook it up, you load the servo library, you sort of say servo.write 70, and then the thing runs over to 70 degrees. Now on the Raspberry Pi, the way we're going to control it is through PWM, or pulse width modulation, and it's setting that duty cycle that's going to control where it is. And so it's a little bit less connected to just simply writing an angle. We're going to have to do it old school. We're going to have to do it old school with PWM. But what's the good news? A couple of lessons ago I showed you how to do PWM, and so actually this is going to be kind of a quick and a fun project. But what I am going to need you to do is I am going to need you to get out your Sunfounder kit. I'm going to need you to get out your Sunfounder kit, and I've got to get mine ready here, so give me just a moment to get everything in proper order and get the right shot here. And so what I'm going to do is I got to move some of this stuff out of the way. Here it is. Okay, get the old overhead shot there, and we have the Raphael kit. So what I need you guys to do is open it up, and for me, in a little bag here in the lower right, inside the bag you will find the servo. Okay, it's this little blue thing, and then also inside of the bag you'll find these little horns or connectors, these little arms. And you can see that you have different types of arms. The one I want you to get is the arm that just has one leg. Okay, so you are going to get this one. You're going to get this one. Then the way I want you to hook it up is with the wires coming out the left and the shaft off-centered to the left. I want you to point that arm back to the right, okay? Now that is going to be our 0 degree angle. We are defining the angle like you would in math. Along the positive x-axis is 0 degrees, and then rotating counterclockwise is a positive rotation. So this would be 0, this would be 90, this would be 180. Does that make sense? Now we're also going to need some wires to allow us to connect this then to the Raspberry Pi. And you can see that our wires on this are brown, red, and orange. And so just to keep things simple and just to keep things straightforward, I'm going to get those same colored wires. So I'm going to get an orange, and that's not the right one. It needs to be a male to female orange wire and a male to female red and brown wire. So those are the wires. That's the servo. That should be the gear that we need in order to get this thing hooked up. Okay, that's the gear we're going to need in order to get this thing hooked up. So what I'm going to do now is I'm going to go ahead and I'm just going to connect these wires with the same color that they are. And so I come over here and brown is on top. And so I will connect brown to brown. Okay, red is in the middle, so I'm going to connect red to red. and I can't see it perfectly because I'm trying to keep it in view for you, and then I'm going to connect orange to orange. Now I don't have to worry about the servo because my color codes are correctly, so I can just kind of move it over here. Now, a couple of things I should say about servos. In general, it's a very poor practice to use your single board computer as a voltage supply or as a power supply, because if you hook a motor or a servo to your single board computer that draws more current than it was designed to provide, you can burn out your board. You don't want to fry your pie, as we have said in the past. The good news is these little tower servos that come with the Sunfounder kit, you can power them off the Raspberry Pi without fear of damaging the Raspberry Pi. But if you get excited about this project and go out and buy yourself a high-tech servo that's this big and try to run it off the power supply of the Raspberry Pi, you're going to fry your pie. So these little ones like this, they should be okay. But let's say that you wanted to use an external power supply. You can power the servo from an external power supply and control it from the Raspberry Pi. So what you need to know is, though, you need to know that on these, the color codes are: red is for the power supply, brown is ground. Wouldn't it have been nice if they would have used black as ground, but they didn't? And the way I remember it, the standard with the servos is usually brown is ground, brown, ground. You see how it kind of rhymes, and that's how I remember it. And then we're left with orange, and orange is control. So today what we are going to do is we're going to power things from the Raspberry Pi. And so I'll come back. You guys should have your pin out printed out already, but I'll bring the pin out up here. And we need, since we're going to be controlling the servo with 3.3 volts, we need to power it with 3.3 volts. So I'm going to get the red pin, and I'm going to connect the red wire and connect it to the 3.3 volt pin on the Raspberry Pi, which is, if you look above me here, which is pin 1. With the USB pointing towards me, that would be the upper left. The upper left pin is 3.3 volts. That's pin 1. Now we need to go ground, and that would be over here on the right column. That would be the third pin down. So the first one is like 2, 4, 6. Okay, 2, 4, 6. And I'm going to check it. I missed it actually, so I am going to go 2, 4, 6 like that. Okay, and that is correct. And now what I want to do is I want to find the first convenient GPIO pins. You can see that you've got pin 8 and 10 are GPIO pins, but I don't like to ever use the UART or the specialty pins for general purpose input output. So the first one that's convenient, I think, is physical pin 12, which is BCM pin 18. And so I'm going to do that. So I'm going to count. They go by 2. So 2, 4, 6, 8, 10, 12, and then boom, I think I am connected up correctly. So I really do indeed believe, that we have this thing hooked up right now, and I think that we are ready to go ahead and get this thing working. All right, I think we're ready to get this thing working. So in order to do that, we're going to have to call up, and I think I can get my no, I think I need to talk to you now a little bit about how to control it. So we've hooked it up, and now I need to talk to you about how we're going to control it with PWM. Okay, so what I'm going to do is I'm going to come over here, and I'm going to switch to my sketchpad view, and boom, it comes up. And this is how we need to control it. And I'm just going to have confidence and have faith that that's going to come back on. Yeah, it does. For some reason, when I switch to sketchpad, sometimes it kind of glitches for about 5 seconds. But remember, the first thing that you have to have with PWM is you have to have a period. Like, what is the period, or the period of time for one cycle? And what we need to control the servo is the period needs to be 20 milliseconds. Okay, so from the start of the cycle to the end of the cycle needs to be 20 milliseconds. If we want to just change that to decimal, that would be 0.02 seconds. All right, so from here to here needs to be 0.02 seconds. But if you remember, the Raspberry Pi doesn't take commands in terms of period. It wants a frequency. So what is the frequency? Well, if you remember, the frequency is equal to 1 over the period. And so the frequency would be 1 divided by 0.02, which is equal to 50 hertz. Okay, so what we've got to remember is when we're setting up our GPIO pins, what we are going to need to do is we are going to need to set the frequency to 50 hertz. So that's kind of like the first thing that we need to remember. Now, the next thing that we need to remember is, as we're thinking about the PWM, that somewhere around a duty cycle, right? The duty cycle is the percentage of the time that the signal is on. Somewhere around 1 to 2% on the duty cycle should be an angle of 0. And then a duty cycle somewhere between, let's say, 10 to 15% should be an angle of 180, and then they should be sort of linear between those two values. But every servo is different, and you're really not exactly sure where to start, but you're not going to go from a duty cycle of 0 to 99. You're probably going to have a duty cycle of something like from 1 to 15, but we need to play around with it to get that. But these are the things we need to remember as we start coding, is these are our values that we're going to need to set up. So hopefully you guys have sketched that down on a piece of paper so that as I switch views here, you will be able to recall those when you need to. So what I'm going to do is I'm going to switch over here to a code view. And I believe you can see that. Yeah, I think you can see that. And then what I'm going to need to do is I'm going to need you to fire up your most excellent Tony. Okay, so I think we're ready to start coding here. So let's think what we're going to need to do. Well, the first thing is we're working with the GPIO pin. So of course we're going to have to import R. We're going to have to import uppercase RP little I dot GPIO as GPIO. You could import it as kitty litter box if you wanted to, but I think GPIO is more descriptive. Now we can say from time import sleep. You might say, why not just import time? But if I imported time to call sleep, I would have to do time.sleep. But from time, if I import sleep, I should be able to give a delay just by saying sleep. So that's just kind of a neat little thing you might be able to remember. Now I've got to do an GPIO.set mode. And this is telling what board numbering scheme that I'm going to be using. I'm going to use GPIO.BCM for the Broadcom method of numbering the board. And that would be, I get so distracted. Sometimes I shouldn't spend so much time with all the nauseating detail, but that's saying instead of the physical pins, I'm going to be using the BCM pins. And then you can see in the BCM land, I will be on pin 18. If I said GPIO.board, then I would be on pin 12, but I don't want to bore you too much with all of those details. So we will come back over here to our code view. And now we've got the board set to BCM, so that's good. Now I need to set my PWM pin, or say what my PWM pin is, and that would be in the BCM scheme. We said that would be pin 18. So let's go ahead and do that. Now we've got to set up that pin. We're going to do a GPIO.setup, and then what are we going to set up? Our PWM pin. and then we're going to set it up as a what? GPIO.out. Now, one of the things that's the most kind of annoying with the Raspberry Pi is how they keep going from uppercase to lowercase to camel case to bumpy font, just to all this stuff. So you got to really pay attention to your case, because some things are uppercase, some things are lowercase, and some things are mixed. And so we got to make sure that we get that all straight. Now we've got to go ahead and turn on or get the PWM set up. So I'm going to create an object PWM, and I'm going to do that by calling it a GPIO dot PWM, and then we are going to set up what for our PWM? We're going to set up PWM pin, okay? And then we've got to give it a frequency. Remember, we want a duty cycle of 20 milliseconds, 0.02 seconds. 1 over 0.02 is 50 hertz. So we're going to set a 50 hertz duty or a set of 50 hertz frequency here. Now we need to go ahead and turn on the PWM signal. So I'm going to do a PWM.start, and I'm just going to start it at 0, so nothing really happens till we get down in the main part of the program. Now we know that we always like to clean up our GPIO pins when we're running a Python program. So we're going to do the try and except thing. So this will be our main program here under the try, and then with except, when we get a keyboard interrupt, which is the Control C, when you get that, what do you want to do? You want to do a GPIO.cleanup, and then what that is going to do is that's going to release the GPIO pins, and then I'm going to print so that I see that that was actually executed. I'm going to print down there GPIO good to go. GPIO good to go, and that just lets me know that those pins have been released and I'm ready to run the program again if I want to. All right, now at first we got to kind of figure out what's the low end, what's the high end, between which different duty cycles do we get live action from that servo. So I think the easiest way to do that is for us to input a duty cycle and then just observe what the servo does. And so what I'm going to do is come back up here to where our main action is going to be in the try, and then I'm going to go ahead and set up an infinite loop. So I'll say while true, when is true true? True is always true. So it will loop in here until it sees the Control C, then it will drop down to the except keyboard interrupt. Does that make sense? I hope so. So we need to go ahead and get from the user, what is the PWM %, right? That would be between 0 and 100, but we want to get values from the user, and so that I'm going to get an input, and that input is going to be prompt him with PWM %, like that. Okay, now if I did this and I put in 12, it would read in 12, but it would read it as a string. So we need to do what to that whole input? We need to float it. Why a float instead of an int? Because, man, if our active region was between 5 and 10, we would want to go like 5.1, 5.2, 5.3. And so we want to have the full range. So indeed, that does need to be a float. So now we've got that number. What do we want to do with that number? We want to change the PWM. So I'm going to say PWM.change duty cycle. Change duty cycle. I want to change it to what? PWM %, that number that I just got from the user. So I'm going to read a PWM value. I'm going to apply that PWM value to my PWM pin, which is pin 18. And then when I do that, I think this thing should change. And then it should come back and it should ask me for another number if I'm thinking about this right. And here, I don't think I'll put in a sleep. It's going to pause and wait for me to put in another number. So I really don't need a sleep, but I'm going to go ahead and put in a sleep of 1/10 of a second, just because I remember if I add a for loop to this or something in a minute, that I'll need to remember to put the sleep. All right, so that is all good. I'm going to come over here and I'm going to lay this out where, again, my wires are to the left and the horn is pointing towards the right. This is called the horn. Okay, you could call it the arm or the lever or whatever, but I think it's usually called the horn. Now we are going to hold our breath and we're going to run this thing. Oh, I see what I did. Did you guys catch that? I didn't put the closing quote there. Somebody didn't hold their breath, and you are the one responsible for that program crash. This time, everyone hold their breath. Okay, look at that. It's asking me for a PWM. I didn't put a space there, and because I'm obsessive compulsive, I'm going to fix that. I'm going to put the space. I'm going to come down here. I'm going to Control C, and then I got the keyboard interrupt. And now, what did I do there? Keyboard interrupt. What did I do wrong there? Boy, that sure looks right to me. Keyboard, not board. Okay, let me go ahead and fix that. It is keyboard interrupt. All right, now let's try it. Everyone hold your breath. Okay, now don't worry about that error. Why did I get that error? Because when the program crashed, it didn't clean up the GPIO pins. So this time I'm going to do a Control C. Now I've got PWM good to go. So now everything should be ready. Hold your breath. Okay, it's asking me for PWM, and I am going to start at 0. It's already at 0, so that shouldn't do anything. I'm going to put a 1 in, and let's just see what happens. Okay, with a 1, really nothing happened. Let's go to a 2, okay? And look at that. With a 2, it went all the way around in a direction I wasn't expecting. So perhaps I should be holding it like this, okay? Do you see how now the board is to the right? Now, with 2, that appears to be the low-end value. When I put a PWM of 2, I have a rotation of 0. Now, if I put 3, it should rotate a little bit. Okay, yeah. 4, 5, boom, look at that. 6, 7, okay, 8. Look at that. At about 8, I'm about halfway around. Then 9, okay, 10, and then 11, and then 12, okay, and then 13. Okay, now look at that. I didn't see any difference between 12 and 13, so it seems like 12 brings me all the way to 180 degrees. So an applied duty cycle of 12 is a rotation of 180 degrees, and an applied 2 is 0. Now let's see, what is the real low end? If I put 1, there's no difference. Let's try 1.1, 1.2, no difference, 1.3, no difference, 1.4, 1.5, almost, 1.6, 2, 1.8. You see, I'm just observing, and what I'm observing is really, I don't see any more movement below 2. And now let's do the same thing at the high end at 12. What if I go 12.2? Okay, nothing more, 12.5, nothing more. What if we go 11.8? Yeah, so you see 12 is the maximum and 2 is the minimum. So applied duty cycle of 2, angle of 0. Applied duty cycle of 12, angle of 180. And so then between 2 and 12, the midpoint would be like 7. And when I go to 7, indeed, that's about 90 degrees. So this is kind of making sense. Boom, look at that. We are controlling a servo. So that's pretty good. Okay, so this has been a quick lesson. Hopefully it's been a fun lesson. Need to give you your homework assignment. What your homework assignment is to combine the stuff that we've been learning in these different lessons, and it's to build a simple demo where you get the, I'm going to give you two possible, I'm going to give you, I'll give you one homework assignment, okay? And then next week I'll give you another homework assignment. But What this homework assignment is to get the potentiometer out of the Sunfounder kit. And when the potentiometer is all the way to the left, the servo is at 0 degrees. And 0 degrees is the positive x-axis. So when you're all the way to the left on the potentiometer, the servo is at 0. And then when you go to the full range of the potentiometer, you go to 180. And I don't want you to kludge it, and I don't want you to guess and check. I want you to do the math with what we know so that that actually really works and you get smooth linear motion on your servo. Smooth linear motion on your servo as you move your potentiometer. And then what you guys need to do is you need to post your homework solution to YouTube, show that it's working, and then show that that it's working smoothly, and give a little narrative. You don't have to go in and show every line of your code, but just basically show that you have it working. Now what I do is I look at every single homework assignment that you post. In your description on your homework, leave a link back to this video, and then down below in the comments leave a link over to your homework solution. And I look at every single homework solution that you guys post. Okay, ladies and gentlemen, I really hope that you are having as much fun taking these lessons as I am making the lessons. And guys, what I'm wanting to do is I'm wanting to get through these components on the Sunfounder kit as quickly as I can. And then what we're going to do is we're going to do some really exciting stuff when we hook up the camera that's in here to the Raspberry Pi. And I've already got a lot of great ideas for that, but we got to kind of learn the basics before we get to the vision stuff. And what I'm going to try to do is a little artificial intelligence stuff. Okay, guys, if you enjoyed this video, make sure to give me a thumbs up. If you've not subscribed to the channel already, make sure you subscribe. When you do, ring that bell so that you get notifications for future lessons. And then make sure that you leave a comment down below, because when you leave a comment, helps me with the old YouTube juice, and YouTube will show this video to more people. And that's important, because the world needs more people coding and doing engineering, and fewer people sitting around watching silly cat videos. Paul McQuitter with TopTechBoy.com. I will talk to you guys later.